Our new topic is determination of action on a beam, which is important topic. Yeah? Actually, all this while I have given you the loading. Yeah. So in design, the loading is called action. So here you will determine what is the type of actions and how to calculate it. Okay, action is actually consists of two important types. It is called characteristic of permanent action, GK. Yeah? K means characteristic. It's similar with the strength, FCK. K is the characteristic. So G here is permanent. And the other one is characteristics of variable action, QK. Q. This is Q and K. Yeah? Since our design now is only consider the beam and also the slab, so we only use these two type of action called permanent and variable. Actually, we have others like seismic load, wind load, and so on. But maybe that is for the fourth year. Yeah. So in this course, we only consider GK and QK. So like strength, we also change the characteristic into design actions. Yeah? It is called WD. Yeah? W means action, D means design, and it is equal because only the two of them, yeah, we consider only permanent action and variable action. So we only have this consideration, yeah, without wind load. Yeah? So it is equal 1.35 GK plus 1.5 QK. 1.35 is the factor of safety for the permanent load, while 1.5 is the factor for the variable action. So you can see here the variable action has higher factor of safety. Yeah. Okay. Okay. Now look at this diagram as well. Variable actions. The meaning is that it is live load. Last time people call it live loads, but in EC they change it to variable actions, meaning that it's like a people of a nature that can be moved or movable in the room. Yeah, like us, we are come and go in a room. Some furniture we can treat it as permanent. Yeah, but if the furniture can be moved and always move, it's called variable action. While permanent action is the dead load due to self-weight finishes. Yeah, for example, the floor, the concrete of the floor, the concrete of the beam itself. Yeah, it is called permanent action. Wall. Yeah, so it is. In other words, it is static. It's not moved. So it is called permanent action. So in a building, that roof is also called dead loads. Yeah? For the floor, yeah, people here live load from the people and furniture. The wall is called also dead loads, yeah? And so on. Yeah. Water is live load. Yeah? Okay. Next one is action and statistical comparison. Yeah. From this figure, last time we have I have taught you about the how to get the strength of concrete and also steel. Yeah. Actually, the curve here is called statistical probability curve. Yeah. So in design, in Eurocode or in other code, usually they will test lots of sample and the strength will be plotted. It is called probabilistic plot. And FCK, yeah, characteristic concrete here or characteristic of steel that we use in design is actually where 5% of the sample fail. Yeah? The strength here is called FCK or FIK. We don't use the 5% at the top tail. Yeah. Okay. We don't take this one. This is also 5% as well. We have two tail here, bottom tail and the top tail. We don't take this. Yeah? This is 0.95. 0.05, sorry, 0.05 at the top and 0.05 at the bottom. So we use this one. In design, we use this strength. We don't use this because if you use this one, not many concrete will attain this strength. Yeah? So therefore, in engineering, particularly, we will use only 5%. Yeah? 5% that pass this strength. Yeah? 95% that pass this strength and only 5% fail. The strength, that strength will be used in the design. Yeah? Therefore, when we get the FCK, this is last time for the material, and then for the material we don't use FCK, yeah, but we reduce it a bit by using the what do you call, factor of safety, right? Factor of safety, gamma F. So we get FCD. Yeah. So this is for the material for the building, and we call it as resistance of structures. But for the load, for the action on the structures, this similar happen. The similar procedure happen here, whereby, for example, the weight on concrete, weight of concrete. Yeah, we test many, like 100 sample. 100 sample is easier for us to calculate the percentage. So let's say we have 100 sample of concrete, we test it, and then we get the load that sustained by the concrete. Yeah, permanent action, we call it permanent action. We get here GK. If we consider the permanent load, we get GK. Yeah, 5% tail, 5% at upper tail. Yeah. For the strength, it is the lowest here, but it is still greater than the GK here. Yeah, so we get GK here, and also QK. Yeah. For example, QK is from people, human people. So what is the weight of the human per meter square? Yeah, per meter square, and then we get a lot of samples, so we can get this probability curve. Yeah, so 95% of them we take it as QK here. Yeah? For the strength we get the 5%, but for the load it is 95%. It's opposite of the strength. Therefore, our design strength WD here is combination of QK and GK. It must be less than the strength of the building. Yeah, here strength of the concrete and also strength of the steel. Yeah, therefore this is the design load must less than strength of the building. So that is the idea of the design, the philosophy of design. Yeah. Okay, so WD here is here, we got here. Is safety factor. Okay, last time the safety factor for the strength is 1.5 and 1.15. Yeah? So this is the basic philosophy of the action on structures and the resistance of the structures. Okay, I need to erase it. Okay, so how do we get the imposed load or variable actions? Yeah. Okay, we have BS6399. Yeah. By referring this code, the code give us what is the appropriate uniformly distributed load and or concentrated load on the floors. Yeah? For example, let's say now we want to design a room, yeah, bedroom. You can see here bedroom. This is example of specific use. For example, you want to design a bedroom in a hotel. Yeah? Bedroom in a hotel. Okay, so what is the value of imposed load? That means what is imposed load is variable action. Variable action is from the people, human, and also the furniture that both can be moved. Yeah? So in that case, we can see here the value is 2.0. Yeah? 2.0. Sorry, my mouse. My mouse not working. So, I don't know what happened to my mouse. Okay. My mouse going crazy here. Okay. So okay. Now the value is 2.0, 2.0 kilonewton per meter square. Yeah. So you can assume either it is concentrated load, if you or uniformly distributed load. Yeah. Basically, we will use UDL. Yeah. So the value is 2.0 kilonewton per meter square. Okay, let's say you want to design a residential, yeah, single family dwelling units. Yeah, the value is 1.5. Yeah, so actually you can get a lot of sample of the minimum imposed floor loads in the BS6399. I will put it this BS in your e-learning. And once we establish the QK, that is called QK just now. This one is QK, this is QK, imposed load, variable action, this is QK. Now, let's say we have established the value. Okay. Now let's say we have a simple floor surrounded by the beam. This is the beam around here, yeah, and this is the column, and we have the dimension of the slab. This is the slab. Okay, so the action here is the WD just now that we calculated, design action. Yeah, let's say this design action just now is kilonewton per meter square because it is acting on the slab. And let's say now we change it to the point load. Yeah? And imagine that the point load, WD, will press at the center of the floor. Yeah. So from here, you can imagine the pattern of cracking of the floor. Yeah. And the pattern of the cracking of the floor due to the design action here will depend on the Ly and Lx dimension. Yeah? So in design, it is very important for us to determine whether Ly over Lx will result one way or two way slab. Yeah? For example, here, now, let's say this is the slab. Just now we have Ly, Lx. Yeah. If our Ly over Lx, you divide it greater than 2, therefore the failure will be along this Ly. Yeah, you can see the crack pattern here, the crack pattern along Ly. Therefore, according to the crack pattern, we can determine the distribution of the load from the slab. Yeah, here shows that half of this, yeah, it's separated by the cracking pattern. So half of this will be supported by this beam. Yeah. Okay, this one will be supported by this beam, while this one, this area of slab, will be supported by this beam. Yeah. As we know that this slab will consist of GK and QK. Yeah. Load from human and also load from the self-weight. Yeah. Okay, GK and QK on the slab. Therefore, now this GK and QK will be separated in two portions. One portion goes to this beam and one portion goes to this beam. Yeah? While this beam will only support itself, right? This beam does not support the slab weight, yeah? Because the crack only cause the slab go to that way and this way and not this way. Therefore, this beam only support itself. Yeah. Therefore, in design, if we want to design this beam, yeah, we must consider GK and QK from the slab and also its self weight of the beam. So how to get GK and QK portion from the slab? Yeah. Okay, so we have here. Yeah. Now look at this diagram carefully. Remember, you must remember, yeah, when the slab is one-way slab, the crack will be happen at the center of the slab, yeah, along Ly direction. This Ly, Lx. Ly is the longer side. Lx is the shorter side. Yeah. Okay. Now, according to the Eurocode, yeah, the coefficients of the load that distributed to the beam, and this beam is 0.5. And this is fixed. The value is fixed. The value is fixed, yeah? 0.5. Okay. Now, if you want to consider, so if you want to consider this beam, yeah, the one that I draw is the beam, this beam, yeah. Let's say that is A, A, this is B, this is B, okay? So the grid here, the grid here, 1, the grid here is 2, okay? Okay, A, B, okay. So now let's say this is our slab with the grid, not grid, yeah, grid A, B, 1, 2. Okay, now let's say I want to design A, 1, 2. This is A. This is beam A. I want to design A, uh, 1, 1, and 2, 2. Okay, so this beam, yeah, the size is BH, yeah, BH. Okay, this is BH, this beam, and it will support the load from the slab. Yeah, the slab, we have GK and QK. So now load from the slab is denoted by the arrow here, arrow down, arrow here. 0.5 QK, yeah, QK, LX, because the slab support QK, LX, this is coefficient 0.5 QK LX, LX, this LX. Yeah? And another one is from the GK, 0.5 GK LX. The unit is kilonewton per meter. Okay, so these two together with the self-weight of the beam, rho BH. Yeah, so that is the total load that supported by this beam. While for B, 1, 2 also has the same load, yeah, has the same load. Okay, now for AB, this is AB, for the AB, yeah, there's no load from the slab. Therefore, it's only support rho BH, it's self-weight only. Yeah. So here A, B. Okay. So it's only support rho BH. Okay. Right. Now, example, yeah. Okay. Okay. Let's say we have a slab 7 by 3. Yeah, this is, yeah, this is, what is it? LY. Yeah? This is LY because this is the longer than this side. So this is LY and this is LX. Okay, let's say the loading on the slab, we have a variable load QK. Yeah, QK here is equal the small QK because I want to differentiate between the load on the slab here and the total here. Yeah, so you can use QK, small QK. Let us erase first. Okay. Okay, now we have a finishers 1.5, slab thickness 1 to 5. Okay, now variable load QK here 2.5. It is obtained from the table just now, BS 6399. And finishers also here we calculate, yeah, this one. This is finishes is like tiles, shielding, yeah. Anything that cannot be moved in a room, it's called finishes, and the total is 1.5 kilonewton per meter square. Okay, so Now we have the thickness here is, sorry, 1150, yeah, sorry. This is 150, correction, this is 150, 150, okay. Okay, now the problem is that we want to find what is the AB, AB2, AB2, what is the loading on A, B. B, yeah. Okay. Okay. AB, 1 or 2. The loading, yes, similar. Correct? So let's say we consider this beam, AB2. So again, as we know just now, yeah, the load is from the slab. The slab, half of the slab, half of the load from the slab will be bear by the AB, yeah, plus with the its own self weight, yeah, self weight. This is the size of the beam. Now, our solution must we divide into two: characteristic permanent action on beam AB2, characteristic permanent action. So meaning that GK. This is GK. GK, the big letter here, capital letter GK. So the first one is beam self weight. What is beam self weight? It is 0.25 the size of the beam times with the density of concrete. You must remember this 25. This is fixed value for the concrete. So it is 0.25 times 0.65, 25. So you got 4.06 kilonewton per meter. The self weight is equal 0, the thickness of the slab times with the density of concrete. Again, density of concrete is 25, yeah, plus 1.5. 1.5 is due to finishers here, yeah. So we get the total on the slab, and this one is total on the slab, 5.25 kilonewton per meter square. So the total GK on the slab now we have 5.25 per meter square. Because this is beam, yeah, we don't want per meter square, we want per meter run of the beam. So we need to change total from the slab to beam is equal this load per meter square times with the coefficient that we obtained just now, 0.5. This is fixed value because of one-way slab, 0.5 times it LX, and this is fixed. You can see here everything is LX, no LY, LX. So you got 7.88. Therefore, the characteristic permanent action on a beam GK is equal 4.06 due to self weight of the beam, add with the total from the slab to the beam, 7.88 kilonewton per meter. So you got 11.94 kilonewton per meter. Yeah. So this is GK. Now we need to find what is QK. Yeah? QK using the formula, it's easy. Using the formula 0.5 LX. The load QK, 0.5 QK LX. So by inserting into the formula, you got 3.75. Therefore, now we got the final value here. QK is 3.75 and GK is 11.94. Yeah, so this is the value on the beam. And then after you got this value, then you can calculate what is the WD. Right. So you can get WD here. WD is equal 1.35 times what is it? 11, right? 94 plus 1.5 times 3.75. So that is the value of design load, yeah, on the beam. So you can get that one, yeah. Okay. Afterward, you can get the moment and shear diagram. That is how we get the action on the beam. Yeah. So the action on the beam is actually from two types of load, permanent and also variable loads. Yeah?